Let us now consider the method called as overlap add. Overlap add method also involves blocks of size n. So n is computed as m plus l minus 1. Meaning of m and l is same as in the previous case. Now, the major difference between overlap add and overlap save is that in overlap add method, the blocks are created in a different manner. To create blocks of size n, we take L data points and then append m minus 1 zeros at the end of each block. Therefore, after the L data points, it is followed by m minus 1 zeros. Finally, after doing the convolution, when we obtain the results, the outputs of the blocks called as y1 of n, y2 of n, y3 of n and so on, they are overlapped in such a way that the last m minus 1 points of the first block, first m minus 1 of the second block and so on, they are overlapped and the values are added. Hence, the method is called as overlap add method. Let us consider the data where h of n is equal to 1, 2 and x of n is sequence of length 12 points. This is the same data we had taken for the previous problem, but the objective here is to understand the difference between overlap add and overlap save methods. We are working with the same constraint that the block size or the size of convolution or the size of TFT is equal to 4. Therefore, from the problem we note that m, which is length of the impulse response, equals 2, n is provided to be 4, L is calculated using the relation between n, m and L. By substituting, we get the value of L is 3. Therefore, we are expected to create data blocks of size 4 by taking L points of data. Therefore, the blocks are created as follows. We take the first 3 data points, append one single zero because the m value in the problem is 2. Therefore, m minus 1 zeros are appended at the last. In accordance with this, we have created 1, 2, 3, 4. 4 blocks have been created. And then possibly we can proceed for the impulse response. The simple impulse response should also be made length n is equal to 4. Therefore, after padding 2 zeros, the impulse response will look like this. In the next step, we can go for convolution. Now, the convolution happens between h of n and x1 of n. And here's the result of the convolution. Next, convolution is done between h of n and x2 of n. And we get the answer. Next, in a similar lines, we convolve and get the results for y3, y4 and so on. So this is the procedure that is to be followed, and we are able to get the outputs of the convolution. It is important to note why we have restricted ourselves to only 4 data blocks, while in the overlap save method we had created a 5th block. Let us just calculate how many data points that we'll actually get as an output by considering these blocks. The method goes something like this. After obtaining the individual outputs y1 of n, y2 of n, y3 of n and so on for the 4 blocks, next step what are we going to do is we will take the output sequence and we'll combine the blocks to get the overall output. This combination happens in the method shown below. First, we align the outputs y1, y2, y3 and so on in a fashion such that the last m-1 points is overlapped with the first m-1 points. This is done at each instance. In this example, the value of m happens to be 2. Therefore, we have only 1 point which is overlapping. Now, after overlapping, the procedure involves adding these two numbers. Now, once we add, we observe that we are going to obtain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 outputs. So what we discovered is that as per the previous numerical, for the linear convolution, we were getting 13 outputs. But overlap save method involved 5 blocks of input. Overlap add with 4 blocks gives you the same amount of output. So beforehand, students, please compute how many elements are required. Accordingly, you are expected to form the blocks. So here, the answer that we get will match that of the convolution between x of n with the long input x of n, that is a long input sequence, with the impulse response h of n, which will result in 13 points being generated as the answer. Thank you all.